All right, guys, this is Algebra 1, Lesson 8.2, Part 2. So this is day 2 of our section 8.2 notes. In the last section, we looked at finding the greatest common factor that we can pull out of a polynomial. So we're going to start with that in our warm-up. So we want to factor out the polynomial using the greatest common factor. Sorry, I have a little bit of a cold. Just ignore that. So we need to find the greatest common factor of 16x and 20x cubed. So between 16 and 20, the biggest number that I can pull out is a 4. And then in terms of the variables, we take the smaller of the exponents. So this one has an x to the 1, so I can pull out an x. So if I pull that out, I need to think, what can I multiply 4x by to get back to 16x? Well, it's just a 4. And then out of 20, I have to have a 5, because 5 times 4 equals 20. And then I need an x squared because I pulled out one of those 3's. So that is done being factored. Okay, on this next one, so what can I pull out of 4, 12, and 8? Well, the biggest number they all have in common is a 4. And then in terms of my m's, I can only pull out one m. So now what do I have left? Well, what do I need to multiply 4m by to get back to 4m to the fourth? Well, I already have a 4, so I just need a 1. You don't have to write the 1. You can if you want. And then I need an m to the third, because m to the third times m will get me back to m to the fourth. Then I need minus 3, because 3 times 4 gives me 12, and then an m, because I have an m squared and I have an m here. And then plus, well, 4 times 2 will get me back to 8, and I don't need any m since I already have the m out here in front. So that one is done. Okay, sometimes the greatest common factor of the terms is a binomial. So meaning I'm going to have like x plus 3 or just two terms that I could pull out. And this greatest common factor is called a common binomial factor. And you factor it out the same way you would if it was a monomial factor, meaning one term. You're just going to keep it as a whole. So let me show you an example. Okay, if I have 5 times x plus 2 plus 3x times x plus 2, if you notice, this x plus 2 is in both parts, so I can pull that out, and then what I have left is I have a 5 plus 3x left. Okay? So basically all we're doing is we're looking for the binomial that's in common, and I'm pulling that out. So in this next one, it's b squared plus 1, and then we use parentheses, minus 2b, and then plus, now since there's nothing written here, it's assumed to be a 1, so we have to put that in. You can't leave that out. I know there's nothing written there. You still have to put that out, because if you were to distribute this back through, we would still get b squared plus 1 all times negative 2b, and then plus 1 times b squared plus 1. So that is our common binomial. So right here is our factored term. So we're going to factor this expression. So we're looking, is there anything that I can pull out in front that's the same that they have in common? No, nothing goes into 4 and 9 evenly. And then let's look at our binomial. Is that the same? It's not. So this one actually has no common factors. Okay. Move this down a little bit. You may be able to factor a polynomial by grouping. So when a polynomial has 4 terms, what you're going to do is you're going to make 2 groups. One group has 2 terms, and the other group has 2 terms. And then you're going to factor out the greatest common factor from each group. So let me show you what I mean. Okay, so if we have this polynomial here with 4 terms, what we want to do is we want to group them like this. So we're going to have 6h to the 4th minus 4h to the 3rd. Okay. And then plus, we got to keep that plus sign, 12h minus 8. Okay, so all I did was I grouped them. Now, looking at this first set of parentheses, what can I pull out between the 6 and the 4? I can pull out a 2, and then in terms of the h, I can pull out 3 h's. So left inside, I have 3h because I have to get back to 6h to the fourth, and then I have a 2. And again, if you went backwards, you should get back to the original. Okay, out of this group, what is the greatest number I can pull out? Well, between 12 and 8, the greatest number they have in common is 4. And then since this doesn't have an h, I can't pull out any h. So to get back, I'm going to have 3h, because 3 times 4 is 12, and h gets me back. And then I need a 2 here. Now, if you guys look, right here, I've got a common binomial that I can factor out, 3h minus 2. And what's left is the 2h to the third plus 4. So this is my factored polynomial, and I did that by grouping. Okay, so same thing. So we have 4 terms, so we're going to group 2 of them together. So I have 5y to the fourth minus 15y to the third. And you don't always have to group it with the first 2 and the last 2. If those don't have anything in common, you could try grouping different terms. You should still get the same answer regardless of whatever you group, though. It shouldn't matter, but you can choose how you want to group it. Okay, I should have a plus sign there, sorry. So out of 5y to the fourth minus 15y to the third, I can pull out a 5 because the 5 goes into both numbers. And then I can pull out y to the third because that's the smaller of the 2. So left inside, I should have y minus 3. Okay? Out of this, I can pull out just a y. And then I'll have y minus 3 left inside, because if I multiplied y back through, I would get to y squared, and y times negative 3 would get me back to minus 3y. Now we've got a common binomial we can pull out of both parts, and I've got 5y to the third plus y. So this is my factored polynomial. If you guys notice down here, I kept a plus sign, and then when I pull out, I've got these multiplied by each other, so just be aware of that. If 2 quantities are opposite, we know their sum is 0. For example, if I have positive 5 and negative 5, together their sum is 0. The same thing's true with a binomial. If I have 5 minus x plus x minus 5, so if you notice, when I add those together, all my terms are going to cancel and I'm going to get 0. So that's something we want to keep in mind, that if they are opposites, their sum will be 0. If you can recognize opposite binomials, that can help with factoring sometimes. So for example, 5 minus x and x minus 5 are opposites. So I could pull out from 5 minus x, I could pull out a negative 1. So let me show you. If I pulled out a negative 1, I would have negative 5 plus x, which if I rewrote that is x minus 5. So just be aware that pulling out that negative can really help sometimes. And it explains it down here too, how that works. So we're going to use that in these next examples. Okay, so we're going to start by grouping. I'm going to keep doing it as the first 2 and the second 2. So out of the first 2, so 2x to the third minus 12x squared, make sure the sign stays there, plus 18 minus 3x. I'm going to pull out 2, and I can pull out x squared because that's the bigger of the 2. So inside I'm going to have an x minus 6 left, plus I'm going to pull out a 3 out of here, so I've got 6 minus x. Well, if you notice, these right here are opposites, so I want to make them the same. So what we said on the last slide is that I can pull a negative 1 out of one of them, and it'll make them the same. It doesn't matter which one you do, it's your choice. So I'm actually going to pull a negative 1 out of the second one. So if I pull a negative 1 out, that makes it negative 6 plus x. It flips the sign. So I'm going to rewrite this down here. Negative 1 times positive 3 becomes negative 3. And then I'm going to rewrite this as x minus 6, just in that order. So now these look the same. So I can have an x minus 6 and then a 2x squared minus 3. Okay, this is going to take some practice, all right? I promise. Pulling out the negative 1, I would just suggest writing, I don't know why that's doing that. Pull out -1 to make an opposite the same. That's going to take some practice. Don't worry, we'll keep doing it. So really what we're focusing on is how can we factor things by pulling out a binomial and even just a regular monomial. Okay, and that's all.